In this tutorial, we will now discuss microscopy. The outline of the tutorial is to first define what is a microscope and then explain how does it work. We will present a microscope that the student will play during the activities. So, a microscope is an optical instrument that can enable the viewing of very small objects that cannot be seen with our naked eyes. There are different types of microscopes. Light microscope use light and electron microscope use electron to image. Here we are in the realm of light microscopy. Here is a photo of a 3D printed microscope called UC2, and at the corner here we can see 3 images of sample we could see from it that was acquired from this microscope using our phone camera. So how does it work? The optics can use a finite system or infinite. In finite optics, the intermediate image where the red line is formed, so this red line, by the object lens only, so it is only formed by the objective lens only, and an eyepiece is to bring that intermediate image to be visible in the plane, in the image plane, and also magnified the intermediate image further. In an infinite optics, an additional lens called tube lens, which is this tube lens, is used, so the object will be placed at the focal position of the objective lens and it forms an image in infinity, and the tube lens will get that image from infinity to form an intermediate image in its focal plane. It is in this red line. The eyepiece will then further magnify the intermediate image so that our eyes can see it. When using a camera, the eyepiece will be replaced by the camera at this position where the eyepiece is. So here is how the that translates to a compound microscope. This example is for a finite optics. The light will be coming from the bottom of the apparatus, indicated by the number 4 here, and focused by a condenser, number 3, onto the specimen, which is number 2, placed at the sample stage. After passing through the sample, the refracted light through the sample will be then collected by the objective lens and form an image which can then be further magnified by the eyepiece for us to see with our eyes. So 2 microscopes that students will be able to use are the portable and the USB digital microscopes. Both of these microscopes use small glass lenses to magnify objects. The digital microscope would require a monitor to display an image, whereas the portable microscope can be seen directly by eye. Examples of samples that they can view are coins, leaves, small circuits, microscopy slides, a screen of a smartphone as well will be very interesting for them to be able to view, especially with the portable microscope. The OpenUC2 microscope is a modular microscope working with finite optics. Optics can be placed inside cubes and cubes can be stacked together to form the microscope. The diagrams need to follow the same diagram as displayed in this slide, how it should be installed. The light source would require some budget to run. Then the sample will be placed in a sample in this sample holder. So the light source will be this. and the sample order will be placed at this position. Underneath it is the objective lens, and how it should be placed. The red band here should be facing the sample, so it should face up, and it will be screwed on a stage that is directing to the Z stage. So this is the Z stage. And then underneath the objective we'll have like a mirror inclined at 45 degrees and another mirror inclined at 45 degrees to reflect the light from the objective and to the eyepiece. And then the eyepiece then collects the image to be directly viewed by eyes. So we can view it directly by eyes here, or we can use a smartphone to image the sample from this. So to adjust the focus, the objective needs to move up and down. So this objective needs to move up and down. So moving this up and down can be controlled by this Z controller by turning the knob on this knob. So this the sensitivity, since we are moving it in micrometer, there is also a limit into how much you can rotate the knob. So the user needs to be very careful. The facilitator needs to be careful in moving this knob to not break the microscope. And the examples of sample to view include biological samples on a microscope slide or living organisms such as ants, insect, worms, and we really encourage creativity to play here, especially for living organisms if times allows. Now to have a deeper understanding on how to stack the cubes and put up the installation, there is this QR code that can be accessed. So the cube it's quite intuitive, but it can also be quite the interaction of the optics matters. Like here, for example, the objective needs to be, the gray one needs to be up, and for the tube lens, for the eyepiece, then it needs to be have a particular direction. So further tutorial can be viewed in this link. And with that, we thank you for your attention, and that concludes this tutorial.